Okay. Zoom is preparing to live stream the meeting.
Excellent.
I'm going to turn off my camera. Okay. Zoom is preparing to live stream the meeting. I'm going to turn off my camera. We are live.
Excellent. So should we kick this off then?
Sounds good to me.
Okay. So hello and welcome to a tour of CI and Kubernetes with Dan and Rob. And what we're going to be doing today is just talking a little bit about the work that CI Signal does to report flakes back to the community of developers who are working on a release. So the CI Signal team is a team that's part of SIG Release, and what SIG Release do is work to shepherd a range of features and fixes into to the next upcoming release of Kubernetes. As part of that work, there's a range of cross-cutting concerns and activities across a number of teams that take place, ranging from bug triage and shepherding features through the KEP process. And what the CI Signal team do is we monitor the signal coming off of end-to-end tests as part of CI in Kubernetes. So what we are primarily focused on is detecting what are called flaky tests. So a flaky test is one that produces a non-deterministic result. That is to say, sometimes it'll pass and sometimes it will fail. And the key point is on the same commit. So in this talk, what we're going to do is going to look at the tooling that we use to monitor the signal, and we're going to just tour around some of the tools on that. We're going to look at how we report flakes, and then we're going to hand over to Dan, who's going to show us examples of fixing the flakes and working with the community to get flakes eradicated because they are a scourge. In terms of how CI Signal works as a team, there is a really awesome. One of the awesome things about Kubernetes is that as a project, the Kubernetes project works hard to bring on new contributors. And it's one of the things that really attracted me to the Kubernetes project when I started out. When I came to Kubernetes first, I hung out with and attended a lot of meetings on the contributor experience project. And it was through them that I learned how the project works, how the project is structured. And through their help, I ended up finding out that my area of interest, because it's naturally CI, I went over to the release team and worked on CI Signal. So I have been the leader of the release, the team lead for the release just gone by. Dan was the team lead for the 1.19 release, and I shadowed Dan on that. So how shadowing works is that there's an application process whereby you can apply to become a member of the team of the CI Signal team and other teams as well. And I just want to talk about that a little bit because as a team lead, your first task is to go through the applications and figure out who you're going to select. And the one thing I just want to note for people who do apply for shadow roles for teams like CI Signal is that the competition is fierce. So that is to say, for the 120 release, I think I had an excess of 80 people apply to be shadows on the team. And then from a management point of view, we can only supervise and train up about a team. The team size is about 4 or 5 thereabouts. So if you applied and you didn't get onto the team, don't be disheartened. Be aware that there's a lot of competition there, and be aware that it's possible to apply again. There will be more releases. The other thing I would say about that is when it comes to application for jobs in the community like that, it's important to remember that if you arrive and apply having done some of the work, there's nothing stopping you from looking for flakes and reporting flakes. And if you're interested in becoming a shadow on the team, it will stand you in good stead if you follow the instructions that we provide today and just muck in and do the work. So with that in mind, bear in mind that we have a Slack channel, Release CI Signal, which I've linked to in the docs there. And if you have questions about this talk or about participating, you can always ask those questions there. And the other important thing to do is to join the SIG Release, and I've links about the SIG Release team there and how you can participate in meetings there. So we're going to get into test grid. I have a small trigger warning. One of the things that we're aware of in the Kubernetes project is that we're working towards replacing harmful language and replacing neutral language wherever possible. And I just like to give a shout out to the working group that's being set up, called the Naming Working Group, which is being set up to look at this across the project. So in on GitHub and in our Git workflow, we have branch names that bubble up into CI, and we're aware of that. And over the course of the coming weeks and months, that's something that we'll be working on to make changes to. So let's just get into it, and let's just have a look. The first tool in the first tool that we have in the chest in order to look at how CI works on Kubernetes, and this tool is Test Grid. So Test Grid, from a release point of view, presents us with a wide range of jobs that run end-to-end tests across multiple run times, and this is our go-to tool for figuring out whether or not a job is flaky and whether or not individual tests are flaky. So this is a summary of the blocking group of jobs, and these are jobs that are considered so important that if they were in a bad state, that would block a release. But we have some flakes here that we can look at. I'm just going to look at some flakes here on one of our jobs, which is the conformance GA only job. Now, so one of the so how Test Grid works is that it basically provides a job view of all of the tests that have been run for an individual job. And in order to make sense of what we're seeing here, there's a lot of tricks that I have in order to figure out what's going on here. The column headers here, give us an indication of the periodicity of this job. So this job happens twice a day. We have times logged in Pacific Standard Time there. If you want to flip that over to your local time, I'm coming from Dublin, Ireland, so that's GMT. I can get a sense that at 5:30 in the morning for me and 5:30 in the afternoon roughly every day. Each cell in Test Grid represents a test result, and green means the test passed, and red means that it failed. So in terms of managing information and trying to get a handle on looking at these failed tests, we have a couple of tricks here that we can, and a couple of options that we can make use of. And typically when I'm hunting for flaky tests, I exclude all tests that have not failed. And that then gives me an easier chunk of information to manage. The other thing that I would often do when I'm looking at this test here, if I mouse over it, the test name is highlighted on the left, and then at the top I can see the date at which the test run, the time it ran. I have a number here that the tooltip says it's build number, but it's really the proud job number. And then below here, this is the commit ID from Kubernetes against which this test ran. So the first thing that I do when I'm trying to figure out is this a flake, is I will mouse over the test. I'll just mouse over to the right, and I'll note that the git commit ID has changed. If I mouse over to the left, the git commit ID has changed. So I'm not 100% clear that this is a flake. But what I want to do is I want to go back in time. If I go back in time, I can look. I'll just get rid of that. If I go back in time, I can see another incident of this test failure. And if I mouse to the right here and mouse to the left, you'll note that I have the same commit ID for this failure. So this is pretty much the definition of a flake. For the commit ID that ends in 3B90F, here we have a pass, here we have a fail, and here we're back to passing again. So by definition, this is producing a non-deterministic test result. For any of the cells, I can click through to get to this view of the job. So this view of the job is presented by a tool called Spyglass, and Spyglass allows us to see how the job was run in Prow. And straight away there, we can see that failing test. And if I just expand on that, we can say that this is the test error message. So this looks like a straightforward test failure insofar as instinctively I know that this probably isn't a runtime issue. Given the name of the test, here, I might actually speak to this because this is a trap for new contributors. So on the left-hand side here, sorry, just go back. On the left-hand side here, we see this test name here. Now, if we want to drill down to the test, we could attempt to do a search for this, but because we have a tool here that allows us to search the repos, and if I pop that in to Hound, we'll see nothing for you, dog. Now, this is because this is not really the true name of the test. So the true name of the test is evicts pods with min tolerations. And I'm going to take this off as well and just do a search for that. And we'll see why this is down here. So if we hop onto this test, 9417. So this is the test that's flaking for us. We can see there, and Dan can speak more to this, and we'll see more of this when Dan does his thing. We have that the name of this test is evicts pods with min tolerations, and it's tagged as disruptive. How the rest of that name in test grid is formed is by traversing down through the hierarchy of the end-to-end test suite that we use to do end-to-end testing. Okay. So the next step is, now that we've identified this is certainly a flake, in real life, what we would do is we check to see if this test has already been reported. So let's have a quick look and see how that would work. If we were to do that from scratch, we would go to issues, Kubernetes issues. And if I dropped in this test name, in fact, I should find this, and we can see that this test has already been logged by scrap codes. Scrap codes worked on, that's Prashant. He worked on the 119. Oh, well, he worked on the 120 release formerly as a shadow, but he actually started working freelance, as it were, on 119. And I showed him how to do this work. But this is an example of a logged flake test where we go through and we describe which jobs are flaking, what the test was, which test flaked, and then we have basically all of the evidence to back up our flake report. So I'll just show you how that works in terms of filling that out quickly, and then I think that will be me, Dan. I think we'll go on to your stuff next. When we log an issue, we have a range of issues that we can report. We have the failing and flaking test, and if we just have a quick look at flaking test, we see that we have a GitHub template that allows us to enter in all of the information to describe the flake that we have found. Now, I think I've linked to Prashant's logging of this in the HackMD. The one thing that I want to quickly point out when filling this, because that's a good example of how to do this, the one thing that I want to just look at here is the triage tool. So in test grid, we can look at jobs from the point of view of all of the tests that run in a job. Okay, so but there are other views that are interesting to look at when we're trying to figure out, well, why is a test flaking? So we have a tool called Triage. And what Triage does is Triage looks at the output of end-to-end tests from the point of view of errors in those tests. So it'll group test failures by error. So if we were to take our test, and that's not what I have in my buffer, bear with. If we were to take this particular test and do a search here for this test in Triage, we'd get useful information that's useful for test maintainers to figure out what's going on here. So one of the key things to figure out when you're trying to deflake a test is you need to understand when and where the test is flaking. So if we look down through, and I might make this a little bit bigger. Let me just have a look here. Okay, is that too big? Okay, so here we've done a search for the test, evicts pods with min toleration seconds. And if I just scroll down here, we can see that there were 17 failures now, 4 today. We'll speak to that in a second. So this test failure occurred in this way across a multiple number of jobs, and that's useful information for somebody trying to triage the test. Let me just see. I just want to scroll down a little bit further, because if I recall in preparing the talk, I think I might have seen this test failed, yeah, on a Windows job. So that means that it failed when running on kind. It failed when it was run in the context of a Windows runtime. So then that's I think that's useful information, Dan, isn't it, for people troubleshooting the test. So I think that's pretty much my walkthrough, Dan. I'm just wondering, are you fielding any questions there or feedback in chat? I can't see it.
So we had one question around if we had a bot to report flakes, because you demonstrated, right, when we can tell for sure that there's a flake. And I mentioned in the channel, the general channel on the Discord server for folks that are watching on YouTube, that the FATA bot will go ahead and record flakes on pre-submits. But we definitely could improve that on the periodics, right? Because there are some cases where we can show that for sure.
Yeah, over the course of the 120 release, I attempted to do a crazy join between the very, very structured data that we get out of test grid and join against the manually logged flakes in GitHub. And although everything is technically possible, the challenge there is that different people log flakes in slightly different ways, so that's difficult to parse. One of the things I will say that is awesome about CI on the Kubernetes project is that data from jobs that are run is collected and put into a BigQuery database. And so our CI process is database backed, which then means that we have tools like Triage that allows us to slice and dice the runtime data in different ways, which helps us get to the bottom of why things are the way they are. At the moment, there's a problem with getting data across to BigQuery, and people are working on that. So you can see there that we have data up to December 1st, but that's something that's been actively looked at, and that's something that we're working to fix. And broadly speaking, the CI Signal team, although it's part of the SIG release team, we work closely with SIG testing because it's their technology that we're using to deliver CI, and we work with testing ops as well. And broadly speaking, the infrastructure which runs CI jobs is very reliable, and jobs are run reliably. And anytime we hit up against infrastructural issues now, it could be to do with configuration of jobs rather than jobs not being run. But I suppose I can hand that over to you, Dan, now from that point there. Yeah.
Sure, sounds great. And that was a great overview of the tooling there, Robin. And one of the things we see when folks come to the project, and from our own experience as well, it can be a little bit daunting to understand like what URL matches what tool and what each tool is used for, and there's some overlapping responsibilities. We also have, speaking for myself and probably the rest of CI Signal members, have an issue of sometimes calling things general names. Like you'll hear a lot of things referred to as prow. For instance, I hardly ever hear anyone say spyglass. And so, it can be a little tough to parse that out. So I just want to, follow up with what you were talking about by saying, please feel free to ask questions. There's no such thing as a dumb question. There's probably tools that we don't even know about, even though we've been doing this for, over a year now. And so definitely feel free to ask about that. But yeah, thanks for that overview, Rob. I'm going to go ahead and start sharing my screen here.
Okay. I'll
Let's
stop my
see.
share.
I'm getting a host as disabled screen
Oh.
sharing, so I might need.
Let me just see. I'm not sure if I can help with that. Let me see.
I might be able to claim.
Let me try.
Oh yeah, it looks like you've got co-host. I just need to grab it.
Okay.
As well. Let's see if I can get some assistance there.
Yeah. Now, Bobby may be able to help us with that.
Yeah, let's see. I'm gonna ping him in the channel and see if he is around.
Yeah.
All right, looks like you already got it.
You should be co-host.
Awesome. Thanks, Bob. All right. So I'll go ahead and share my screen here. And I always have trouble with this Zoom overhang.
You should be co-host already.
Cool. Sounds good. I think I've got it. Let me do one thing real quick and I'll reshare again. All right. So we are set to go here. And so Rob's given us a nice overview of all the tooling and how to interact with it and that sort of thing. And, you know, there's miles more layers to it. And a lot of that you experience when you actually try to, you know, track down what issue you're seeing. So in my personal experience, as Rob mentioned, I kind of came to Kubernetes through SIG release and started out in CI Signal and did a lot of the issue logging and that sort of thing. And then the more I did it, the more I became familiar with the fixes that were coming in for different SIGs and became more involved with that. And so you'll start to see that, especially if you spend a lot of time on CI Signal, you know, you'll start actually starting to fix some of the bugs yourself. So we're going to walk through some of that. Another advantage of walking through it is you see how, you know, your workflow through these different tools we've seen goes. So I'm going to go with a few different kind of like cherry picked issues that we've had over the last few months that demonstrate different scenarios you'll run into when trying to troubleshoot. So this should also be useful for folks who are not interested in CI Signal, but, you know, work with a SIG or doing feature work and get pinged to fix something that they introduced. So Rob kind of called out already that flakes and failures are kind of the two main categories of I guess failures that we're going to see here with tests. And so there's three different main categories you can run into when something is failing, right? It's either a bug in the code. So the actual code base, the actual Kubernetes code base, there's a bug in an implementation there. So that's what you generally think of as the purpose of testing. So that could be one situation. Another could be a bug in the test, which means, you know, we're testing the wrong thing. So that could be another, and we'll walk through one of those. And then the last one, which can be the hardest to track down, especially if you're not involved with SIG testing or SIG release, can be an issue with infrastructure or tooling. And there's a lot of different things that can go wrong there. So I have a few different examples that we'll walk through. But without any further ado, let's go ahead and start with a bug in the code, which is kind of the most straightforward example. So this is an issue I opened on November 11th. This was an informing job that we have on GCE Ubuntu master default. And you'll see this issue format that Rob already detailed. And so I basically just followed the general thing. I got a ping that this test was failing, went ahead and looked at the board, which this board will be out of date at this point, but went to this job and saw that it was consistently failing at this point, which is why it'd be a failing test rather than a flaking one. So we had red all across the board here. So I opened it up, gave it the failing test label. This is informing, and we wanted to get this fixed up for 1.20. As Rob said, informing jobs do not have to be passing for us to go ahead and release. That being said, it's definitely concerning when something is consistently failing, no matter where it is. So once again, I have the output here of what we were getting from the job. And the next thing to note is the SIG, right? So how was I able to determine what SIG this went with? So primarily it had to do with a Docker exec liveness probe. So obviously Docker is running as the CRI implementation on a node. and that would, cater to something in sig node. So I went ahead and put that sig node label on it. I also was able to determine a PR that introduced this failure. So once again, as Rob was already detailing, when you go through here, we can look at both the Kubernetes commit hash as well as the test infra commit hash, which I'll hop over to the test infra repo in a minute because that's where a lot of this tooling lives, as well as the configuration for all these dashboards. So when I actually looked at the job that I opened this issue for, there was a distinct change in commit hash, which went from green to red. And so I was able to tell, it likely was introduced by whatever happened between these two commit hashes. And if you're not familiar, GitHub actually has a pretty useful way to, it's not what I meant to do, to compare commit hashes. And there's some shortcuts to be able to get this open. But here's just an example I have in my search history here. But you can actually just supply the first commit and the second commit separated by an ellipses. And you'll see all the commits that happen between those two. So this is actually for a different failure that I was tracking down that I have cached here. But I'll use this as an example. You can see here that all these commits are part of a single PR. So likely whatever started failing, if it went from green to red between those commit hashes and there's only one PR, we can go ahead and determine that that was probably the PR that introduced whatever caused the failure. So this is not the test that we're looking at right now, but this was a similar situation where I was able to narrow it down to one PR here. So looking at this PR, we can once again see it's kubelet work. So it is in sig node. You could also see that by the labels on it. And then Andrew, who makes lots of different contributions to the Kubernetes project and is a very important contributor, had introduced some new functionality to respect exec probe timeouts. And we go back over here, you'll see I went ahead and tagged him on here and kind of gave some context around the issue. The first thing that I wanted to realize is if this caused a consistent failure, how is this merged, right? So when we look at the release dashboards here, we're looking at periodic jobs. So as Rob said, that means, right, that we're running them on a consistent cadence that you can see here at the top, the difference between the hours that they're running and the time. We also have pre-submits. So the ones running on a cadence are periodics. The ones that run on a PR before it goes in are called pre-submits. And so let's just go to a recently opened PR. We can see who our winner is. Let's look at this etcd version 1 here. So you'll see that there are lots of jobs here that are running against the PR before we merge, and those all have to pass if they are merge blocking. And so how did we pass all of those tests, right, and get something in that then caused a periodic job that is fairly critical with it being on the informing board to fail? Well, if we go back and take a look at the job that was failing, we can see how it's configured and potentially what jobs ran that did pass. So I'm going to go over to Spyglass here as Rob showed. And there's a number of different things up here that are helpful links to artifacts from different job runs. So you obviously have a link back to test grid. Artifacts is going to show you all of the artifacts from that test run. So you can see the proud job configuration, the start and stop things. And then you can also see the different output from things like the node logs and that sort of thing. So once again, looking back at this, the proud job YAML is what is going to tell us how this job is configured. And I believe here, if we search for it, the important thing on this job was actually that we are running with kube container runtime Docker. And if we flip back over here, this obviously had to do with the Docker exec liveness probe. So if we look back at the job, it also has some similar jobs, some similar tests running against it. And let me hop back over here one more time to see if we can pull out the specific job here. node end to end. So we have pull Kubernetes node end to end, which sounds pretty similar to, well, not that similar to GC Ubuntu master default, but if we look at the end-to-end tests here, we can see that it's running similar ones. And if we hop back over to the node end-to-end though, and take a look at the proud job YAML, you'll see that it's not specifying Docker as a container runtime. And I won't go into exactly why we're able to determine that a different container runtime is being used. But basically, this is using container D under the hood. So the fix here was that we had run tests. We had run tests against one container runtime, but this actually was a change in a different container runtime, Docker versus container D, which we can talk about Docker shim and some of the deprecation around that and what the difference between Docker and container D are, but I'll leave that to a different talk. But essentially, right, we were running this test for this scenario against a container runtime where it wasn't being exercised. And you'll see here in the discussion, my initial inclination was that we were using incorrect version markers, but Andrew did a little more digging, and we were able to see that it was because of the container runtime. You'll also notice that this was running with a different operating system, as it's obviously running on Ubuntu. So that was something to take in mind. The pre-submit was running with the Google Container OS. And so that was another thing to investigate. Anyway, Andrew was able to go through this and find an appropriate fix for it. Went ahead and tagged me on it to let me know, which is really helpful if you're a contributor and someone has pinged you to fix a test, if you tag them on it and reference it. So you'll see here, we were eventually able to get this in. I believe we talk a little bit about running this test in the specific job. Yep, so you'll see here, and we'll talk about what this means in a little bit. But during this PR, Andrew temporarily added this node conformance tag onto the test, which made it get exercised by the test that was running. And so we got an idea of whether it was passing or not. So that allowed us to, using the pre-submit, be able to determine if this was going to actually fix the problem. So that's kind of a walkthrough of a typical or somewhat typical bug in the code. So new functionality was introduced, it broke something, it passed the pre-submits, and we caught it in the periodics. Another follow-up to an action like that is determining maybe we should be running this test on the pre-submits, right? If it's going to cause breaking changes, maybe we need to be exercising that code path. All right. The next thing that we could look at is a bug in the test, right? So for any of these jobs, essentially what's happening for most of them, and I'm excluding build jobs and things like that, ones that are actually running things from our end-to-end test suite, what's happening is they're not rebuilding Kubernetes and running it each time, right? They're getting the latest version of the Kubernetes release, so the latest build of it, depending on the job. And it's going to download that, and then it's going to clone the repo for the tests that are in the KK repo. Also, just to make sure that we're defining everything well, KK is a common acronym to refer to Kubernetes repo, as there's many repos under the Kubernetes org. So if we look in test here, primarily we're thinking about these end-to-end tests here. So what happens is these jobs will go ahead and download Kubernetes, they'll run it, and then they will exercise the tests in the test subdirectory here against the version that they've downloaded. If it's something like SIG release 1.20 blocking, you'll see, and let's look at one here real quick just to demonstrate this. Let's see if this has the extract information here. You'll see that we want to use the latest 1.20, whereas we look at the same job on the master branch here. Let's see, I think it was the ingress one. You'll see that we are just doing latest fast, which is actually a fast build. Well, we won't get into fast builds today, but essentially they're building for a single architecture. an operating system rather than the general build, which builds for all. So yeah, based on the the version that we're trying to test, we'll download a different version of Kubernetes and clone that branches tests and run them against it. All right, so back to this example of a test failing because a bug in the test. This was one that once again flipped from green to red, but it was just flaky, right? So we introduced a new test and it didn't actually just cause things to consistently fail, but we could tell from the scroll back, and I just have this from context, but we could probably find one here as well. Let's see. One of these might be a good example. So this one is having a pretty consistent flake rate. But if you had something where it was, green for 30 columns or something like that, and then it suddenly started turning red every other column, that would be a good indication of when the code was introduced that caused the flake. So in this case, I wasn't able to pin it down to a specific PR. So you'll see that I have my emphasized might be related to here, this PR. So I was able to determine when the flake rate increased and guess on the PR. It looks like I was, let's see if that was the, oh no, that was an issue I actually tagged. So it looks like that Morgan here was actually able just to watch for this. And this is a example of the benefits of tagging folks that are responsible for a certain area of the code base. So Morgan was able to follow up and say, oh, I know exactly what's happening here because Morgan had context that I didn't have, which is really useful. And said, I can do the fix here, went ahead and assigned themselves to it and provided the fix and tagged me on it. And this is a really good example of what could cause flakes based on how the test is designed. You'll see what Morgan's doing is relaxing the matcher here. So for this specific test, it has to do with the resource metrics API. So we're looking at the metrics that are produced. And initially, when this test was introduced, it was match all elements. So basically saying, I expect the metrics that we see to look exactly like what I'm specifying here. So no more, no less. And for the ones that we have to look exactly like these ones I've provided. In reality, that wasn't what we needed to test here. We just wanted to see that these two that we were interested in were present. And if we had, a million other ones, that was all right. So you could see how this could produce flakes here, right? Because sometimes there may be other metrics, sometimes there may be not, depending on what else is running in the cluster and exposing this. So we can just change this to match elements and ignore the extras here. And that turned us back green. So that was a very quick fix here. And you'll see we got that in for 1.20. And one thing I wanted to point out here, which Rob actually brought up when we were going through kind of the preparation for this, is you'll see this gstruct here package. And let me go up to the top and see where that's coming from. So you'll see this is coming from Gomega here. And essentially what it's doing is allow us to match the contents of structs here. But I wanted to point out that we use some external frameworks alongside the kind of end-to-end framework in the end-to-end tests. So Gomega would be one of those which can help out with, diffing different structs and that sort of thing. But the primary one that you're going to see the use of, potentially controversially, is Ginkgo. So Ginkgo is used across a lot of our tests, and you'll see it used to do things like set the context or run things before each. And the particularly important one that Rob was pointing out earlier when searching with Hound is this Ginkgo it, which is prepending information onto the front of this kind of description here. So you'll frequently see, if we're looking at, let me go back to one of these and see if this wasn't a failure. Let me grab a failure and see if this has it. So yeah, this is a good example here. It's probably prepended this Kubernetes end-to-end suite, may have done SIG storage, probably this CSI mock volume, CSI volume expansion. And then we probably just saw should expand volume by
Mm.
restarting pod if attach on node expansion on, which looks kind of like what we're seeing here with should report resource usage through the resource metrics API. So when you get more familiar with interacting with some of these tests, when you see a failure, it's a little bit easier to go ahead and pull out what to search for. But it can definitely still be challenging. Also, the tags here, like SIG storage, can help you identify, what part of the end-to-end testing framework to look in. Rob, did you have something you were wanting to bring up?
Yeah. So the way I think of that, or the way I think of that name is, it's almost like it's a flattened hierarchy of the Ginkgo traversal down to the test. So what Ginkgo is trying to do is to trying to describe in English what is happening, where it's happening, how it's happening. So that's, you typically find that in end-to-end test frameworks where you almost want to be able to just have an English statement of what the expected behavior of the test is. So I think the ultimate next step up would be have Cucumber and just be able to have end users read what is happening under the hood and just extract out those English statements, so that people who aren't into the test but are interested in the expected behavior can read those off. But that's for another day. That's another day's work. We've plenty to be getting on with, I think, as it stands now.
Absolutely. And as Rob says, there's lots of areas for improvement. One of the things I want to point out here, since we're talking about finding the actual test failure, obviously a good place to look here is, the code where the failure happened, right? So we have line numbers here because they are Go tests that are being run. Sometimes you have to follow this a little bit to, figure out where it actually happened, because the way that things bubble up with Ginkgo, like if you're doing a before each or something like that, the failure may be on line 66 because of this failure down here. So that's typical Go testing stuff. And once again, if you have questions on any of these practices, definitely feel free to drop them in the SIG release channel or CI signal specifically, if you like them in relation to that. One other thing that I want to mention with Ginkgo, and this can probably lead a little bit into looking at test info repo as well, is, and this was actually really evidenced by this failure that we saw on GC Ubuntu master here. So let me grab that real quick. Is these test args that we passed. So you'll see, as we've already shown in a number of different test failures that we've looked at, we have these indicators in the brackets here. So basically tags on the different tests. And that allows us to choose different tests that we want to run based on the tags that they have, right? So here in this end-to-end GCE one, we want to skip all tags that have, or all tests that have tags that are slow, serial, disruptive, flaky, or are a feature test. You could also do things like Ginkgo Focus, which says only run tests with these tags, and then you can combine skip and focus, right, to get a specific subset. So a good example of that is one that Rob was actually looking at earlier, I think, conformance GA only. I would guess here, and I haven't looked at this recently, but I'd guess that we have a potential skip. Actually, maybe not on this one. Let me grab another one here. All right, so this one is a great example. So this job is testing the device plugin for GPUs. And so it's a very focused test, right? So you'll see here that we're passing in Ginkgo Focus featured GPU device plugin. If we actually went over to KK here, and let me grab that again. I'm going to pain everyone and use the GitHub search, but should be pretty easy here. So you'll see here that there's only really one area where we're running, or potentially two areas where we're running GPU device plugins here. So it'd be really easy to troubleshoot an issue with this, right? Because it either happened here or here, likely. So there's only really those tests that we're running. And we'll actually talk about this test in a minute as well. So when I pull up this proud job YAML that's configuring how everything is run, where does that come from, right? Well, test infra is probably where you're going to spend most of your time if you're really interested in this whole CI signal and testing um, uh, realm. And you'll see some of the different names that we already mentioned here, some of them that we didn't yet. A lot of these are used to either build images that are used to basically bootstrap the tests, or their frameworks like kube test, which allows you to spin up the Kubernetes cluster in a consistent way and test against it. You'll also see prow here, some test grid stuff, although test grid is a separate repo. And there's lots of different things in here. And one of the things, and I think there's an issue open to it, but some of the tools are outlined here, but it'd be really great if we could get a diagram, right, that showed how all these tools interact with each other, and get an overview of this. I know this is something Rob is passionate about, for sure.
This is well, you want the diagram when you're starting out, and then as you learn it, you go, yeah, it's okay. They'll just talk to each other. But one of the we're having a lot of chatter in chat about data retention and how CI is data backed. So Carlos is asking some good questions about how far do test grid results go back. Broadly speaking, there's two aspects to data storage from running CI jobs in the Kubernetes project. The metadata is, I think, loaded up by kettles, which is what Dan is visiting there now. So that's Kubernetes extract, test, transform. That's the ETL. Yeah, it's a I don't have great stats on the amount of data going into BigQuery, but I just know instinctively they're using BigQuery for a reason. It's a lot of data. So metadata pertaining to jobs should be funneled into BigQuery. When it comes to job artifacts, the limiting resource there would be buckets. It's GS, isn't it? So yeah, it'd be data storage buckets there. So, and like Dan is saying, all of these tools are, for the most part, they're pretty much in test grid. Test grid is, I suppose, it is a mono repo with a lot of tooling in it, and when I suppose the most famous one, or the application that I know that has moved out recently, has been test grid. So the back end of test grid has been open sourced, and the front end is still is not yet open sourced. There's a lot of little things that I'd like to do for the CI signal use cases there, but when it comes to getting expert and deep knowledge, if you log issues on the new test grid repo, and if you make suggestions for front end changes that you would like to have happen, if they are implementable, the team who work on test grid will make those changes for you, and they're awesome to work with. I speak to Michelle Shepherdson, who works on that project once every 2 or 3 months, and we talk about what we'd like to have happen on test grid, and she's awesome. She does great work on that.
Awesome. Thanks for pointing out, Rob. And that's a great point. A lot of these issues that I'm going to here, I'm not really able to show you exactly what was happening at that point in time. And if we have that data still available, we could present it. But I also don't have all the context as well on what the data retention story is there. We will talk in a bit about how some of the infrastructure management works and that sort of thing. But the main thing that you're probably going to be interacting with, at least when you first start out with interacting with test grid, or if you are just a SIG owner or something like that, is the config directory. And if we look at jobs, and Rob, you may have already said this, but I wanted to point out once again, these different tabs here. Well, first of all, the tabs at the top, right, are dashboards. They're test grid dashboards. Each of the tabs listed under a dashboard are jobs, and then each of the line items, well, build master fast was not a great one to pick for that. Here we go. Each of the line items here is a test that is being run. So it may just be me, but when I first started out with CI Signal, it was really difficult to me because sometimes we'll say, like this test is failing and we really mean a job, or, this job is failing.
Yeah.
And on all of our issues, which this is something that I've kind of pushed on in the past, we'll say failing test. And sometimes this is an example where I actually have the test listed here, but sometimes we'll have a job name. If we aren't able to pin it down to a single test or it's a lot of tests failing, and we'll say failing test this job name, which it kind of is true, but it's not as exact as I'd like it to be. So anyway, something to keep in mind. It goes dashboards, jobs, tests. And as I mentioned, all of these job configs and then the association of the jobs to the dashboards that they're presented on in test grid all lives in test infra. And so we'll primarily be looking at the Kubernetes one here, where you'll see all the different SIG ones. Specifically for SIG release, we can look at the release branch jobs, which these are actually auto-generated. Maybe we'll have some time to look at the tooling as well that makes this happen, but there's too many things to cover all of them. But you'll see these are all periodics, right? Because as SIG release, we're primarily interested in those. You'll see that we have things like the test grid dashboard as an annotation, which says, this belongs on 1.17 blocking. We'll have alert emails. So you'll see the release team on all of the ones under SIG release. And then you'll also see the appropriate group for the SIG that may own that job if there is one. If it's something like general end-to-end test, there may not be a single SIG that owns it. Go ahead, Rob.
So one of the things that might be worth pointing out here as we look at this is that as part of the efforts to corral and manage and tend to CI jobs on the project, we have organized sort of like a program of work in order to maintain these jobs. And so there was a release where we were getting a lot of noise in our signal pertaining to jobs not stating their resources properly. So as we look at their from line 36 down to 42, this job is requesting limits in CPU and memory and requests for CPU and memory, and a lot of jobs didn't have those resources specified. So as a result, it made the scheduler difficult. It made life difficult for the scheduler to schedule those jobs on the infrastructure. So from the point of view of finding work to do, I'll add the project board to the HackMD, but but the SIG testing team and Aaron Quickenberger did great work with Laurie Apple to set out the program of work whereby that SIG testing team and testing ops could get help from the community in order to improve CI configuration on things like that.
Yeah, absolutely. And since you bring that up, a good thing to remember with all of these different tests is that they are running in a Kubernetes cluster themselves. So they get scheduled to a node. So they're essentially, just how pods get scheduled in Kubernetes, these jobs are running in pods on a GKE cluster, actually. And here you'll see that we have the resources for them. So that controls how they get scheduled to the nodes, right? So for instance, maybe if I find one of the kind jobs here, they have pretty heavy CPU requests. In fact, this actually means that they have to run on a node by themselves based on the node size that we're running. And if there isn't a node available in the cluster for a job to run, then you'll see it gets failed to schedule after a timeout of something like 5 minutes. And that's one of the examples I have here in a moment. But that's the general idea. So yeah, all of the jobs live in the test infra repo. And another thing I want to mention is the same job may be on multiple dashboards. So for instance, this one on 1.17 blocking, it's a conformance job. So if you want to go to here and look at conformance all, we would see, all these different version conformance jobs here also on this dashboard, right? So a job being on a dashboard does not mean it's only there. And this allows for different SIGs to, prioritize different jobs that they want to look at. And there may also be, other SIGs or other groups that are interested in their status as well. All right. So many things. It's hard to get them all in there, but we're going to try. Also, I know we are kind of like reaching the hour. Rob, as my counterpart in this talk, how are you feeling? You good to keep going?
I'm good to keep going, yeah.
All right. Well, Bob, if you need to kick us off, you just let us know. But I've got a little bit more here, and we'll keep pushing until someone tells us we're not allowed to anymore. All right. So this is an especially fun one, which let me close out some of my tabs here. And this is actually, I can see my phone blowing up a little bit with some messages about this because it's not completely resolved yet. But I chose this well, it's really more than just failing tests, but there were quite a lot of failing tests, and this is very recent. So you'll probably see that they're still there. Probably on 1.20 blocking, we should be able to see some of them. I believe all of these Kate's beta ones are failing. Let's go back a bit. Yep. All right. So you'll see that this immediately started failing here. And none of the tests were actually even being run. So if we click on one of these, you'll see the extract step here, which is basically where we download that version of Kubernetes based on the version marker that we have, was failing, right? So we weren't able to run any tests because we weren't even able to get a Kubernetes cluster to test against. And if we look back at the commits here, number one, we see here that the infra commit didn't change. There is a change in commit hash for the other indicators here, but it went to missing. So this isn't really helpful, right? If we can't get the Kubernetes cluster, we don't get some of this information, which there's various improvements that can be made there as well. But something that I had from context, and also seeing that this started happening across other blocking job boards as well, which we can see once this loads. It was a shorter time for 1.19, which we'll see why in a second. This basically started happening across all different branch blocking boards. So the immediate thing I thought was, when's the last time that we released? Well, we just had a 1.20 release, the 1.20.0 release. And it was about the same time that the jobs on 1.20 started failing. And then the next day we had patch releases for all the different branches, and that's when they started failing. So there was probably something wrong with that release. So it turned out that we had some faulty logic in our release tooling that led to, we can go to this. Well, I should have just clicked on all releases here. You can see that, for instance, the 1.15 or the 1.17.15 and the 1.17.16-RC.0 are on the same commit here. And what we want to do is actually separate those commits so that we're able to determine they happened at different times. Because they were on the same commit, all of the builds that were happening, which we'll do this for 1.20. And let's find one of the builds that, let's see what day these are on. I think it's this one. But essentially, well, we could actually also see it from that one we were looking at earlier with the extract here. The version marker that we're using is saying it's 1.20.0-1 plus the digest of the hash there. And what it should be saying is RC dash whatever, or RC.0 dash whatever for 1.20.1, right? We're moving towards the next release. And that wasn't happening because of those commits being on the same hash. And the way that version marker gets there is when this build job runs. So, right, we have to build these versions for the test to start using. When they ran, based on the version that we are building, we'll say publish extra version markers. So for instance, here we're saying publish a Kate's beta version marker, and then it also sees that we're on the 1.20 branch here. So if we look at some of the logs here, you'll see that we're publishing extra version markers. And then if we go down and actually look at the copy, let's see if I can find it. Yep. So here you'll see that we're publishing version markers, latest 1, latest 1.20, and Kate's beta. All right. And Bob says we do need to wrap up soon.
We're getting
So
flashed.
yeah, I'll basically say that we were building on the wrong commit. And this is just an example. The reason why I bring this one up is this an example of something that had nothing to do with bad code in Kubernetes, bad tests in Kubernetes, or even the infrastructure that the job was running on. There's an issue in repo machinery. There's an issue in our release process that caused the version that we were using to not match a regex that basically said this is an appropriate version to download and use to run tests against. And maybe we can follow up with a separate discussion that talks about all the different layers that this exposes of traversing, from code in the release repo to code in test infra to code that's in Kubernetes to download and extract that version. But this is an example of how difficult it can be to find why a test has started failing. So definitely always ask for help, right? Because there's other people who have context that you may not have. And the last thing I want to point out here is this is an example of a pod not being able to be scheduled. So this is what Rob was talking about, right? With those requests and limits. It basically says there wasn't an available node due to either insufficient memory or taints on the nodes or insufficient CPU. That basically said we weren't even able to attempt to run this job. And that's something that, and I think that this one I did here, that's something that you may want to open on test infra, right? To say there's an issue with either our job configuration or our underlying infrastructure.
Yeah, and I think it's worth saying that a massive amount of work and effort goes into keeping everything up and running from a job running point of view, and it's no small undertaking, and the team that keep things up and running are awesome. They do great work, and when there's problems, they're very, very responsive.
Absolutely. I should probably close this one
So
out.
I think
Looks like it hasn't failed.
Yeah, so I think we're gonna maybe finish up there. Just thank you, Dan, for all of that good info. You can see you can see how far ahead Dan is on the CI signal journey than I am, and
I think we have different expertise. I'm not farther ahead,
Yeah,
just in a different place.
Oh, but you're doing the fun stuff that I want to do next, So, so I'd just like to thank everyone for attending. What I would say is, if we want to follow up with the team, you can reach out to us on release-ci-signal on Slack, on Kubernetes Slack. And if you have any further questions that you want to ask, you can follow up with those questions there. Broadly speaking, there was a lot of interest in what data goes where and how long that we can see data for. And Josh Burkus has pointed out a few features that he'd like to see in test grid. And I'd say to Josh, log them as issues on the test grid repo. If they're doable, they'll get done in time. And just thanks to everyone for the questions, and thanks to Joyce Kung for providing support during the chat as well. Joyce is going to be the new team lead for CI Signal for the 1.21 release, and so really looking forward to that. And yeah, I think we can wind it up there, Bobby, and end the meeting. Thanks, Dan.
Yeah, thanks, Rob. Thanks, Bob.